Hi everyone, today we're going to be talking about both exponential growth and decay. I'm also going to be talking about half-life situations, so you might want to watch the second video I have posted that talks about half-life. Remember, our exponential function is a times b to the x, where a is our starting amount, and b is our growth or decay factor, and x is our time period. Skipping the video about half-life, but understanding the concept of half-life. If we have an initial amount, we want to know the first half-life is when half of it remains. Second half-life, 25%. Third half-life, 12.5%, and so on until you get down to really small amounts. But it will never completely get to zero. Here we have an isotope of barium. It has a half-life of 13 days. That means every 13 days, the amount that's left will be cut in half. So if you have some, after 13 days, we have half, and then we have a quarter, and then we have 12.5%, etc. So we want to know, it says that 100 grams of the barium disintegrates over a period of 52 days. How much would be left? So my starting point for my barium would be 100. I have 100 grams of it. And this half-life, so we're talking 1/2 is the amount it's decreasing. You could put 0.5. Every 13 days. Well, we're talking about how many half-lives this is. Well, one half-life is 13. 2 would be 26. This would be 4 half-lives. So this would tell us how much is left. So if I do 1/2 or 0.5 to the 4th power and multiply that by 100, it will tell me that I have 6.25 grams remaining after 52 days. And if you think about that, at the start I'd have 100. After 13 days, I would have 50. After 26 days, I would have 25. After 39 days, I'd have 12.5. And after 52 days, and I would have 6.25, going down by half each time. Times 1/2, 1/2, 1/2, 1/2. Okay, let's look at this iodine. We have radioactive iodine. And we want to know how much will be left after 120 days. If we start with 720 grams and the half-life is 15 days. Well, we want to know how many 15-day periods fit in 120 days. So 120 divided by 15 will give me 8 time periods. Oops, 8 time periods. We know we're starting from 720 grams. And again, we're talking half-lives, so it's going to be 1/2. So 1/2 to the 8th power times 720 will give me 2.8125 grams remaining after 120 days or 8 15-day time periods. My next example, it says a lab technician is culturing bacteria. Current population is 2,000 bacteria and it's tripling. So this is not a half-life situation. This is growth. It's tripling in size every 4 hours. How much bacteria will be after 1 day? Well, we're starting with, let me get my pen on. We're starting with 2,000 bacteria. That's my starting point. And we know it's tripling, so it's multiplying by 3. It's tripling every 4 hours. And we're saying how many after 1 day? Well, 1 day is 24 hours. How many 4-hour time periods are in 1 day? That would be 6. So 2,000 times 3 to the 6th power will give me a lot. 1,458,000. That is huge. It grows fast when you triple. Think about that. After one 4-hour period, I'd have 6,000. After 2 3-hour periods, I would have 12,000. So it grows very fast. And 36,000. Then we're into the 100,000s. So it grows very quickly. Okay, here I have termites again. I like to talk about these termites. Gross. It says there's 150 of them. And it says they also double, so that's times 2, every 45 minutes. How many will there be after 540 minutes? Well, we got to know how many 45-minute time periods there will be in 540 minutes. And that is 12. So we're 12 time periods. Do you think we'll have a lot of termites? I think we will. 150 times 2 to the power of 12 gives me 614,400 termites. That's pretty gross. Here we have barium 122, has a half-life of 2 minutes. So we weighed it. It's 80 grams. We're talking half-life, so it's going to be 1/2. And it takes 10 minutes to set up the experiment. So how much will be left when the experiment begins? Well, if its half-life is 2 minutes, how many 2-minute periods fall in 10 minutes? That would be 5. So 80 times 1/2 to the 5th power gives me 2.5. 2.5 grams will be remaining by the time we start the experiment. Half-life for uranium-232 is 70 years. That's a long half-life. How many half-lives will it take for 10 grams of it to be reduced to 1.25 grams? So we have 10 grams and its half-life. And we want to know what that time period is for it to equal 1.25. Well, we know it's not 1, because 1 will bring it to 5. 2 half-lives, if I put 10 times 1/2 to the 2nd power, that would be 1/4 of 10, which is 2.5, but about to the 3rd power. Oops, that should be 1/2. I wrote the 3 there accidentally. 1/2 to 3rd power is 1/8. 1/8 times 10 is 1.25. So that is my correct answer. Now, how many years is that? That's 210 years. Remember, each half-life is 70 years. Mrs. Nader deposited $560 in her bank account that earns 15% annually. That would be a nice interest rate. 560 is how much she's depositing. That's her initial amount. We want to know how much money she's going to have in 3 years at 15% interest. This is a growth model, 1 plus 0.15 to the power of 3. And I get $851.69. That's a pretty good return. Now we have Mrs. Johnson. She put 300 in her account that earns 5% annually. So 300 in her account. And she's only earning 5%. So 1 plus 0.05. How much will she have after 2 years? I don't think she's going to have as much as Miss Nader. Looks like she'll have $330.75. So, just a quick review. We want to find what's a constant factor of change for each one. Remember, if it's doubling, we have 2. If it's tripling, that will be a 3. If it's a half-life, it will be 1/2. And if it's a percent increase, it'll be 1 plus our percent. If it's a percent decrease, it'll be 1 minus our percent. So try to keep track of all of those. But we always use the same type of formula, a times b to the x. That's it. Have a great day.